In April 1942, the Baton Peninsula held a peculiar prize in a Japanese military depot, a captured American reconnaissance vehicle, its massive 6-inch tires still caked with dried mud. The machine sat waiting, unremarkable at first glance. Colonel Tetsuo Iwakuro circled it slowly, studying the welded steel body with careful attention. 2,450 pounds of American engineering stared back at him. Crude, inelegant, almost insultingly straightforward. By comparison, the Type 95 Kurugane scout cars represented something altogether different. Mechanical poetry, each one. Precision components fitted with meticulous care, elegant solutions realized in steel and aluminum. The Japanese military had built nearly 4,700 of them since 1936, each a small masterpiece of manufacturing refinement. When the Imperial Army directive reached Kichiro, Toyota, the task seemed straightforward enough. Design and construct a Japanese equivalent to this American vehicle, 6 months to completion. His engineering team gathered around the disassembled machine and saw opportunity in every joint, every weld, every component. That transmission was unnecessarily heavy. Those suspension parts could be lightened considerably. The body panels seemed thick enough to protect against artillery. "We can build this better," Toyota declared with quiet certainty. "Lighter, more efficient, more reliable." Then the material allocation arrived, and the engineering mathematics collapsed like a structure with a faulty foundation. 2.1 tons of steel for 6 prototypes. The numbers simply refused to work. The American vehicle consumed 1.4 tons per unit. Even accounting for superior Japanese manufacturing techniques, the allocation made no logical sense. Japan attempted to copy the American Jeep that year, but they were about to learn a fundamental lesson about manufacturing that would reshape their entire understanding of industrial production. Through the spring of 1944, that captured American vehicle became Kichiro Toyota's obsession. 2,450 pounds of crude American engineering gnawed at him constantly. Something about its brutal simplicity persisted in his thoughts. Each morning, he walked through the Kuromo plant floors where Toyota's craftsmen assembled Type KC trucks with the precision of master watchmakers. Every component received individual fitting. Every measurement met exacting standards, precise to the millimeter. Chief designer Kazuo Kumabe spread the American vehicle's technical drawings across his workspace like a surgeon examining X-ray photographs. The frame rails used 14-gauge steel, thick, heavy, wasteful in every respect. The suspension components appeared as though forged by a blacksmith rather than machined by skilled engineers. The transmission housing could have weighed half as much with proper Japanese manufacturing techniques applied. "Look at these welds," Kumabe said, his finger tracing the photographs. "A first-year apprentice could perform better work than this." His team of 12 senior engineers nodded in complete agreement. Toyota had devoted decades to perfecting manufacturing techniques that produced vehicles of extraordinary precision. The Type 95 Kurugane scout cars represented the absolute pinnacle of Japanese automotive engineering. Each one a mechanical masterpiece built with rigorous attention to efficiency. Iwakuro Toyota, only 22 years old and determined to prove his worth to the family name, performed careful calculations on the improvements they could achieve. Frame weight reduced by 23% through superior steel selection. Fuel efficiency improved by 18% with a lighter transmission design. Reliability increased by 30% through better electrical systems. The numbers painted a compelling picture of inevitable Japanese superiority. The AK-10 project launched with characteristic Toyota precision and methodical planning. Kichiro assembled his most capable team, Kazuo Kumabe directing design excellence, production manager Hiroshi Nakamura managing manufacturing efficiency, and his son Iwakuro overseeing systems integration. Their target specifications exceeded the American original across every measurable category. Weight target of 890 pounds against America's 2,150. Fuel consumption of 18.7 miles per gallon against their 14.2. Ground clearance of 9.2 inches versus their 8.5. The first serious doubt appeared on a grey April morning in Nakamura's material requisition office. The supply manager's weathered features carried troubling news before he even spoke. Steel allocation for the AK-10 project, 2.1 tons monthly. Rubber allocation, enough for 12 tires total. Copper wiring allocation, 14 pounds. Toyota stared at the figures, his engineering mind automatically calculating the impossible mathematics involved. The American vehicle consumed 1.4 tons of steel per unit. Even with Japanese efficiency improvements, building 6 prototypes would require at least 4 tons of material. The mathematics were undeniable and devastating. There must be some error, he said, though they both already knew better. Japan's industrial capacity was hemorrhaging resources toward more critical military priorities. Steel went into submarine pressure vessels, rubber went to aircraft tires and tank treads. Copper went to electrical systems for radar installations and naval communications. Nakamura produced reports that revealed an even grimmer reality. Japan's total military vehicle production across all manufacturers totaled 88,000 units annually. America's Ford Motor Company alone had produced 277,000 vehicles in 1943. The scale difference wasn't incremental. It was civilizational in its magnitude. Yet Toyota's engineers pressed forward with characteristic determination. If abundant materials weren't available, they would compensate through superior intelligence and engineering excellence. Kumabe redesigned the frame using 16-gauge steel instead of 14, compensating for reduced strength through geometric optimization. The transmission shed 47 pounds through precision engineering, while incorporating an additional gear ratio. Every single component reflected decades of Japanese manufacturing refinement. The first prototype emerged from Toyota's assembly halls on July 15, 1944, like a mechanical sculpture. Elegant, efficient, perfectly balanced. Testing vindicated every specification. The vehicle climbed 45-degree slopes, where the heavier American original stalled at 38 degrees. Fuel efficiency numbers validated Japanese engineering philosophy. Precision over brute force, intelligence over abundance. Colonel Iwakuro arrived for the demonstration with a procurement committee of Imperial Army officers expecting to witness Japanese industrial superiority in action. The AK-10 performed flawlessly through mud tests, steep gradient climbs, and obstacle courses that would challenge vehicles twice its weight. Every system functioned with clockwork precision. "Excellent work," Iwakuro declared, making notes in his leather portfolio. "How many units can you deliver by December?" That question represented exactly what Toyota had feared most. He had prepared his answer through weeks of increasingly depressing production calculations. With current material allocations, approximately 50 vehicles total. Toyota replied. The silence felt like a physical weight pressing down on the demonstration area. Iwakuro's pen ceased moving. 50 vehicles, total? Yes, sir. Current steel and rubber allocations limit our production capacity to roughly 8 units monthly through the remainder of the year. Iwakuro set down his portfolio and fixed Toyota with the stare of a career military officer accustomed to overcoming impossible obstacles through sheer determination and will. The Americans are producing 600 Jeeps per day. 600 per day. The figure struck Toyota's engineering team like artillery fire. That translated to 219,000 units annually from a single vehicle type alone. Toyota's entire automotive production in 1943 had totaled 16,102 vehicles across all models combined. In private, Iwakuro revealed the full scope of Japan's industrial crisis. Steel production has declined 37% from peak levels. Rubber imports have ceased entirely. We're operating on stockpiles. Every copper wire in this factory could serve better purposes in submarine electrical systems. Toyota requested a meeting with supply coordination officers, hoping to negotiate increased material allocations. His presentation proved methodical and compelling. 200 AK-10 vehicles monthly would require 47 tons of steel, 4,000 tires, and 180 skilled machinists. The specifications were precisely calculated and completely impossible. We have 82 tons of steel available monthly, the coordination officer explained with bureaucratic patience. Maximum rubber allocation, 200 tires. Skilled machinists currently unassigned to essential war production, 23. The mathematical reality crushed Toyota's ambitions beneath the weight of industrial physics. They could build perfect vehicles or adequate quantities, but Japan's resource foundation made both simultaneously impossible. American production philosophy suddenly revealed its terrible logic. Good enough, fast enough, cheap enough. Build 600,000 acceptable Jeeps rather than 6,000 perfect ones. Walking through the Kuromo plant that evening, Kichiro Toyota finally understood what the captured American vehicle had been attempting to communicate. Its crude welds and heavy construction weren't design flaws, they were production features. Built for manufacturing speed rather than engineering elegance. Designed for 10,000 factories rather than 10 master craftsmen. Japan had spent decades perfecting the art of building individual vehicles. America had perfected the science of building vehicle production systems. In industrial warfare, the side that built more would defeat the side that built better, regardless of quality superiority. The AK-10 prototype took shape through April and May 1944 like a mechanical sculpture carved from scarcity itself. Every line on Kazuo Kumabe's blueprints represented a compromise between engineering ambition and material reality. The original frame specification called for 14-gauge steel rails, providing structural integrity comparable to the American original. Available material consisted of 16-gauge steel, reducing load-bearing capacity by 23%. Shui Kairo Toyota spent sleepless nights in the engineering halls, slide rule and calculating machine, working through stress analysis that would compensate for weaker materials through superior design. His solution proved elegant in its complexity. A triangulated frame structure that distributed loads through geometric precision rather than brute material strength. The mathematics proved flawless. The manufacturing requirements proved punishing. Each frame joint required 17 individual welds performed to tolerances measured in fractions of millimeters. A single misaligned connection would cascade structural weaknesses throughout the entire vehicle. Toyota's master welders, craftsmen with decades perfecting their art, could complete one frame per week, working extended 12-hour shifts. American production lines, according to intelligence reports, stamped and welded Jeep frames in 47 minutes using semi-skilled workers and automated equipment. The transmission presented an even more sophisticated engineering challenge. The American Bantam used a simple 3-speed manual gearbox weighing 112 pounds that any competent machine shop could manufacture. Kumabe's team designed a 4-speed transmission with synchromesh gearing weighing only 65 pounds and delivering smoother power delivery across a broader operating range. The weight savings proved substantial. The complexity increase proved exponential. Manufacturing the new transmission required 47 precision machine components, each held to tolerances demanding Toyota's most experienced machinists. The gear teeth alone required 18 hours of hand finishing per transmission unit. The American Jeep transmission, crude as it was, relied on standardized parts that could roll off automated production lines. Factory workers with minimal training could assemble these components with routine efficiency. Then came May, bringing rubber allocation through Japan's characteristically rigid bureaucratic channels. The entire AK-10 development program would receive exactly 12 tires, just 12. Testing the prototypes would be stripped down to bare essentials. No extended endurance runs, no field trials to explore real-world conditions, no room for mistakes or mechanical failures. Nakamura worked through the rubber calculation with methodical precision, each number reflecting harsh reality. The AK-10 needed 4 operational tires per vehicle, plus 1 spare. If they tested 3 prototypes simultaneously, their entire rubber supply would vanish. Nothing left for the remaining 3 vehicles. Nothing left for replacement tires if testing uncovered design flaws. Meanwhile, across the Pacific, American Jeep factories consumed 18,000 tires every single day across all their plants. Yet Toyota pushed forward with the determination that defined Japan's industrial spirit. The AK-10 promised to outperform the American vehicles across the metrics that actually mattered for military operations. Fuel efficiency climbed 23% higher than the Bantam original. The weight-to-power ratio improved by 18% through engine refinement and structural redesign. Ground clearance gained 0.8 of an inch from suspension modifications. Where American Jeeps relied on simple 6-volt electrical systems with minimal instruments, the AK-10 showcased Toyota's technical sophistication. The AK-10 featured 12-volt electrical architecture powering comprehensive engine monitoring systems, advanced lighting and radio integration calibrated for Japanese military communication standards. The wiring harness alone contained 237 individual connections, every one hand-soldered and wrapped in insulation engineered to withstand moisture, vibration, and temperature extremes. Building these electrical systems consumed Toyota's entire copper allocation for May and most of June. Each vehicle demanded 14 pounds of copper wiring against the American Jeep's 8 pounds of cruder components. The superiority was unmistakable, yet the resource price was crippling. Nakamura stood before the first completed prototype mock-up in early June, conflicting emotions churning beneath his engineer's disciplined exterior. Pride in what his team had created, anxiety over what it represented. Every component embodied the pinnacle of Japanese automotive engineering. The hand-polished aluminum engine block weighed 37 pounds less than the American cast-iron equivalent, while delivering superior performance through precision manufacturing. Suspension components were machined to tolerances that eliminated play and vibration while cutting weight by 42 pounds. The vehicle stood as a mechanical masterpiece, yet Nakamura grasped with crystallizing clarity that masterpieces represented Japan's fundamental strategic vulnerability. American intelligence reports filtered through military channels, decoded and analyzed by Toyota's production team, revealed the staggering reality of Allied industrial output. Willys-Overland's Toledo plant employed 1,896 workers, producing 442 completed Jeeps daily. Ford's River Rouge complex operated dedicated assembly lines, manufacturing 600 vehicles per shift through standardized components and interchangeable parts. The production mathematics defied comprehension in their implications. American Jeep manufacturing cost $648 per unit through mass production techniques, prioritizing quantity over individual vehicle perfection. Toyota's AK-10 projected to cost $2,100 per vehicle, and that assumed unlimited materials and a workforce expanded by 300%. Nakamura presented these calculations to his father's attention, laying out Japan's industrial reality with mathematical precision. Current Toyota capacity consisted of 47 skilled machinists, 12 master welders, 6 precision engine builders. To produce meaningful quantities of the AK-10 would require 180 machinists, 60 welders, 30 engine specialists, plus dedicated assembly line infrastructure needing 8 months for construction and commission. Training replacement workers to Toyota's quality standards demanded 18 months of apprenticeship under master craftsmen already working beyond sustainable limits. American production lines, according to decoded reports, trained semi-skilled workers to perform specialized assembly tasks in 2 or 3 weeks, using standardized procedures and automated tooling. The prototype testing phase revealed both the triumph and tragedy of Japanese engineering excellence. The AK-10 outperformed the captured American vehicle in acceleration, fuel economy, handling precision, and component reliability. Independent military evaluators praised its superior build quality, noting that panel gaps measured in fractions of millimeters and mechanical tolerances approached Swiss chronometer precision. Yet each test consumed irreplaceable resources. Tire analysis required rotating the limited rubber allocation between vehicles, preventing simultaneous testing of multiple prototypes. Fuel consumption measurements depleted gasoline reserves, requiring weeks to replenish through Japan's strained logistics network. Component failure analysis meant hand rebuilding specialized parts that American factories would simply replace from warehouse inventory. By late June, Toyota had completed 3 AK-10 prototypes, representing individual triumphs of engineering artistry. Each vehicle embodied 47 years of Japanese automotive development, incorporating lessons learned from silk weaving machinery to aircraft engines. they demonstrably outperformed their American counterparts in every measure of individual quality and performance. They were also impossible to manufacture in militarily significant quantities using Japan's available industrial resources, skilled workforce, and raw material allocations. Nakamura's perfect engineering had created perfect vehicles for an imperfect war. American crude effectiveness was defeating Japanese refined excellence through the simple mathematics of industrial capacity multiplied by time. The lesson crystallized with mathematical certainty. In mechanized warfare, adequate quantities defeated superior quality, regardless of how superior that quality might be. The first complete AK-10 rolled out of Toyota's assembly hall on July 15, 1944 at 11:30 in the morning. 340 man-hours of skilled labor had transformed raw materials into a vehicle representing everything Japanese engineering could achieve under wartime constraints. Every component had been hand-fitted by master craftsmen. Every weld had been inspected under magnification. Every measurement verified to tolerances that would have impressed Swiss clockmakers. Nakamura climbed behind the steering wheel for the initial test drive, feeling the precise clutch engagement and smooth gear mesh that had consumed months of development time. The engine responded with mechanical poetry. No vibration, no rough idle, no uneven power delivery. The steering tracked perfectly straight. The suspension absorbed road irregularities without transmitting harshness to the cabin. Performance testing began immediately on Toyota's proving grounds, a compact facility carved from agricultural land behind the Koromo plant. The AK-10 climbed a 45-degree slope that had stopped the heavier American Bantam at 38 degrees. Fuel consumption measurements showed 18.7 miles per gallon compared to the American vehicle's 14.2. Acceleration from 0 to 30 miles per hour required 12.4 seconds versus the Bantam's 16.1. Every metric confirmed Japanese engineering superiority. The AK-10 was lighter, more efficient, more responsive, and more refined than its American counterpart. Nakamura watched the testing with satisfaction, tempered by growing awareness of what these achievements actually meant in the context of global industrial warfare. Colonel Iwakuro arrived on July 20th with a full procurement committee and expectations shaped by years of Japanese technical excellence. The demonstration proceeded flawlessly through mud courses, steep gradients, and obstacle navigation, showcasing the AK-10's superior agility. The vehicle performed with mechanical precision, impressing even experienced military engineers who had tested countless equipment. Outstanding work, Iwakuro declared, making detailed notes about performance specifications exceeding requirements. This vehicle represents the finest reconnaissance platform our forces have seen. When can production begin? The question that had haunted Nakamura through weeks of sleepless calculation. With current material allocations and manufacturing capacity, we can deliver approximately 50 units by year-end. Iwakuro's pen stopped moving. The procurement committee exchanged glances conveying months of frustration with Japan's industrial limitations. 50 vehicles for the entire Imperial Army. Current steel allocation permits 8 vehicles monthly through December. Nakamura explained with the precision of an engineer delivering unwelcome mathematics. Rubber allocation limits tire production. Skilled workforce availability restricts assembly line capacity. The colonel closed his notebook and requested private discussion. In Nakamura's office, away from the engineering team, Iwakuro revealed production reports painting a comprehensive picture of Allied industrial capacity. American Jeep production had reached 600 units daily across multiple manufacturing facilities. Ford Motor Company alone was producing more military vehicles monthly than Japan's entire automotive industry manufactured annually. 600 per day, Iwakuro repeated, the number hanging like artillery smoke. That's 219,000 vehicles yearly from a single vehicle type. The mathematics proved devastating in their implications. Toyota's total automotive production in 1943 had been 16,300 vehicles across all civilian and military models. America was producing more Jeeps in 3 weeks than Japan built vehicles in 12 months. Nakamura requested detailed material requirements for scaled production, hoping to identify bottlenecks addressable through resource reallocation. Manufacturing 200 AK-10 vehicles monthly would require 47 tons of steel, 4,000 rubber tires, 180 skilled machinists, and dedicated assembly line infrastructure currently used for essential truck production. Current allocations provided 8.2 tons of steel monthly, 200 tires maximum, 23 available machinists. The gap between requirement and availability wasn't incremental. It was categorical. Japan's industrial base couldn't support meaningful AK-10 production without abandoning other critical military manufacturing. Nakamura presented a comprehensive analysis of American production methodology based on decoded intelligence reports and captured equipment documentation. Willis Overland's Toledo plant employed 1,896 workers, organized into specialized assembly teams. Each worker performed specific repetitive tasks using standardized tools and procedures. Component manufacturing relied on automated machinery producing thousands of identical parts with minimal skilled oversight. American Jeep production cost $648 per unit. Toyota's AK-10 manufacturing cost $2,100 per vehicle, assuming unlimited materials and expanded workforce. The price differential wasn't about profit margins. It reflected fundamental differences in production philosophy. American manufacturing prioritized standardization over optimization. Jeep components were designed for mass production rather than individual excellence. Tolerances were adequate rather than precise. Materials were abundant rather than efficient. The entire system was engineered for quantity production by semi-skilled workers using automated equipment. Japanese manufacturing traditions emphasized individual craftsmanship and component optimization. Each AK-10 represented accumulated expertise of master mechanics who had spent decades perfecting their skills. Quality standards exceeded functional requirements because excellence was considered inherently valuable. This approach produced superior individual vehicles at prices making mass production impossible. Intelligence reports revealed the scale of American industrial mobilization with mathematical precision impossible to dismiss. Ford's River Rouge complex had converted automobile assembly lines to produce B-24 bomber components, Jeep engines, and tank transmissions simultaneously. Chrysler Corporation was manufacturing complete Sherman tank powertrains using automotive production techniques adapted for armored vehicle requirements. The numbers painted a picture of industrial capacity dwarfing Japan's entire manufacturing base. American steel production reached 89 million tons annually against Japanese production of 7.8 million tons. American aluminum production hit 920,000 tons versus Japanese production of 142,000 tons. American automotive industry workforce numbered 460,000 skilled and semi-skilled workers. By August, Toyota had completed all 6 AK-10 prototypes, each requiring specialized attention from engineers and craftsmen who could have been building essential military equipment. Quality control had rejected 0 components, a manufacturing miracle demonstrating Japanese technical excellence while highlighting the impossibility of scaled production. Each prototype represented different optimization approaches: weight reduction, fuel efficiency, component simplification, manufacturing cost reduction. None addressed the fundamental problem of industrial capacity constraints making mass production impossible regardless of engineering excellence. The final prototype testing revealed performance exceeding every specification while consuming resources Japan couldn't afford to invest in vehicle development. Tire analysis had exhausted rubber allocations. Fuel consumption measurements had depleted gasoline reserves. Component durability testing had consumed machine shop capacity needed for aircraft engine manufacturing. Nakamura presented his father with production scaling calculations, laying out the mathematical impossibility of meaningful AK-10 manufacturing. Current Toyota capacity could theoretically produce 96 vehicles annually, using every available resource. American Willys Overland was producing more Jeeps in 4 days than Toyota could manufacture in 12 months using their entire industrial infrastructure. The lesson crystallized through arithmetic no amount of Japanese determination could overcome. Superior individual products were irrelevant if you couldn't produce enough to influence military outcomes. American crude effectiveness was defeating Japanese refined excellence through the simple mathematics of industrial capacity, multiplied by time, multiplied by available resources. In mechanized warfare, the side building more vehicles would defeat the side building better vehicles, regardless of how much better those vehicles might be. By late July 1944, Toyota's engineering halls displayed 6 completed AK-10 prototypes, like mechanical trophies and a museum of impossible ambitions. Each vehicle that rolled off Toyota's workshop floor represented 340 hours of meticulous, skilled work. This wasn't just assembly, it was the concentrated genius of Japan's finest automotive engineers poured into a single reconnaissance machine. The quality control records spoke for themselves with unmistakable clarity. Not a single component rejected, not one assembly error, not a trace of performance failure when the prototypes underwent their initial trials. But production numbers told an entirely different story, and it was one that couldn't be ignored. Production manager Nakamura laid out his scaling analysis across the conference table, where Toyota's executives gathered. Everyone in that room sensed this was the moment everything would be decided. The numbers were exact, thorough, and absolutely crushing. To manufacture 1,000 AK-10 vehicles every month would demand 47 tons of steel. The current allocation, a mere 8.2 tons. They'd need 4,000 rubber tires while permissions allowed only 200. The operation required 180 master machinists when just 23 existed. A dedicated assembly line would be necessary, yet the only factory floor available was already committed to producing KC trucks, the lifeline keeping Japan's logistics network functioning. "We can manufacture perfect vehicles," Nakamura stated with the measured tone of someone delivering inevitable bad news. "We cannot produce enough vehicles to make any difference." The words hung in the air. Kumabe examined photographs of American manufacturing plants obtained through military intelligence. The images showed something that would have seemed impossible just years earlier. The Willys facility in Toledo stretched across acres of factory space where nearly 1,900 workers were turning out 442 completed Jeeps daily. They accomplished this using assembly line methods that prioritized speed and efficiency over the individual craftsmanship that defined Japanese tradition. Each worker performed narrow, specific tasks that could be mastered in just 2 or 3 weeks, compared to the 18-month apprenticeships required under Toyota's exacting standards. The American approach relied on interchangeable components manufactured to acceptable tolerances rather than perfection. Jeep frames were stamped from standard sheets and welded using automated equipment that guaranteed consistency without needing master craftsmen. Engines used cast-iron blocks that were heavier than Toyota's precision aluminum work, but this allowed them to use foundry techniques demanding minimal skilled labor. Ford's production figures revealed the true scope of American industrial might. The River Rouge complex alone employed 95,000 workers capable of rapid retraining as military requirements shifted. Automotive assembly lines had been converted to manufacture aircraft engines, tank transmissions, and artillery shells using the same standardized techniques that made civilian vehicle production so remarkably efficient. American Jeep manufacturing reflected this philosophy entirely. They cost $648 per unit through systems engineered for quantity, not individual excellence. Toyota's calculations for AK-10 production showed $2,100 per vehicle, and that assumed unlimited materials and a tripling of their skilled workforce, something that would take years to achieve and decades to master at Toyota's demanding standards. The resource allocation meeting in early August provided final confirmation of Japan's industrial ceiling. Steel production had dropped to 7.8 million tons yearly as raw material imports declined and mining operations shifted to more pressing military needs. Rubber stockpiles were nearly exhausted, with no feasible synthetic replacement available in the quantities needed for vehicle production. Copper was allocated to naval ships, aircraft electrical systems, and communications equipment rather than vehicles. Colonel Iwakuro attended with procurement specialists carrying detailed analyses of Japanese versus American production capabilities. The classified information was undeniable in its implications. America's automobile manufacturers combined were producing 2.6 million military vehicles annually across all types. Japan's entire automotive sector, encompassing Toyota, Nissan, and smaller producers, had built just 88,000 military vehicles in 1943. This wasn't a simple gap, but a fundamental difference in how industrial warfare was conducted. American manufacturing emphasized adequate quality produced in overwhelming quantities. Japanese traditions prioritized superior individual products, requiring craftsmen and resources Japan could no longer sustain. Reports from Pacific Theater operations provided perspective on these production differences. American forces received continuous replacements and upgrades, while Japanese units operated with vehicles deployed since the war's opening months. As spare parts dried up and replacement vehicles vanished, maintenance became nearly impossible. American abundance was defeating Japanese engineering. Kichiro presented his comprehensive analysis to Toyota's leadership in a presentation that laid bare the mathematics of industrial defeat. American manufacturers had repurposed automobile assembly lines for military equipment, using mass production methods Japan had never developed meaningfully. Ford, General Motors, ASC, and Chrysler combined employed more automotive workers than Japan's entire heavy industry workforce. The AK-10 represented Japan's fundamental miscalculation about industrial warfare. Superior individual products meant nothing if they couldn't be produced in quantities sufficient to supply fighting forces. American Jeeps might seem crude by Japanese standards, yet 600,000 crude vehicles would overwhelm 6,000 perfect ones through simple arithmetic of battlefield presence. By mid-August, the contradiction between Japanese engineering mastery and industrial reality became undeniable. Toyota's 6 AK-10 prototypes functioned flawlessly in testing, proving superior fuel efficiency, climbing ability, mechanical reliability, and overall refinement compared to captured American vehicles. They also consumed Japan's entire monthly allocation of automotive materials, while producing just 6 vehicles unable to alter military operations meaningfully. American production thinking suddenly made strategic sense, viewed through resource allocation and manufacturing scalability. Adequate vehicles built quickly by semi-skilled workers, using standardized components and automated assembly, justified themselves. Design focused on manufacturability rather than individual optimization. Component tolerances emphasized interchangeability over precision. The entire framework was engineered for maximum volume, using available industrial resources. Manufacturing traditions producing peacetime automotive excellence became wartime strategic liabilities. Master craftsmen capable of building perfect engines were irreplaceable resources requiring decades to develop and impossible to scale rapidly for wartime demands. Precision methods that created superior individual vehicles consumed materials that could have equipped multiple adequate units using American techniques. August 14th brought the final reckoning when B-29 superfortresses appeared over the Toyo plant at 11:47 in the morning. The bombing destroyed 23% of Toyota's manufacturing capacity, including precision machine shops where AK-10 components had been crafted by irreplaceable master craftsmen. 18 months of development work disappeared in 18 minutes of high-explosive devastation. Standing among the smoking ruins, Kichiro Toyota finally grasped the fundamental truth that had eluded Japanese industrial leadership throughout the conflict. They had manufactured superior individual vehicles through excellent engineering and techniques. America had manufactured superior production systems, overwhelming superior individual products through sheer volume and capacity. The captured American Bantam remained in the depot yard, still functional after 3 years of examination. Its crude welds and heavy construction embodied design philosophy prioritizing mass production over excellence. 600,000 adequate vehicles would defeat 6,000 perfect ones consistently, regardless of perfection. Japan had lost before the Pacific War even began, defeated by Detroit's assembly plants and industrial philosophy. 5 days after the emperor's surrender announcement, Kichiro Toyota sat alone in his office, with AK-10 project files spread like archaeological remnants of Japan's industrial misconceptions. Outside his window, the captured American Bantam remained in its courtyard spot of 3 years. Its crude construction now revealed a story Japanese engineers had misunderstood in 1942. The mathematics of defeat lay before him in precise columns, documenting every AK-10 stage. 6 prototypes completed at $47,000 total cost, using materials that could have built 37 essential KC trucks for Japan's collapsing logistics. 340 work hours of skilled labor per vehicle, while American lines produced Jeeps at 2.6 hours using semi-skilled workers and automation. Each AK-10 embodied everything Japanese engineering could achieve under wartime conditions: superior fuel efficiency, reduced weight, improved climbing, mechanical refinement exceeding American standards in every category. They were demonstrably superior vehicles built by demonstrably superior engineers using demonstrably superior manufacturing. They were also strategically meaningless, a war decided by industrial capacity rather than individual product excellence. Toyota opened his leather-bound wartime journal and wrote what would be his final entry on the project, consuming 18 months of Toyota's best engineering talent. We believed superior craftsmanship could overcome industrial capacity. We were profoundly mistaken. In modern warfare, the side building more vehicles wins, not the side building better vehicles. The Americans grasped something we missed. Perfect engineering means nothing without perfect supply systems. The numbers told the complete story with mathematical certainty no Japanese determination could overcome. American Jeep production from 1941 to 1945 totaled 634,569 units. Japanese AK-10 production across the same period, 6 prototype vehicles never deployed to combat. American factory capacity had been designed for volume using standardized components and interchangeable parts. Japanese manufacturing had been optimized for individual excellence using master craftsmen and precision methods. Shoichiro entered his father's office carrying production reports from Allied industrial surveys revealing the true scale of American manufacturing power. Ford's Willow Run plant had produced 8,655 B-24 bombers using automotive assembly line techniques adapted for aircraft manufacturing. General Motors had converted Cadillac factories to produce tank engines and artillery shells while maintaining reduced civilian automobile production. "We learned the wrong lesson from the Americans," Shoichiro said, setting reports beside the AK-10 files. "We tried copying their vehicles. We should have copied their methods." The insight would reshape Toyota's post-war understanding of industrial production. American success hadn't come from superior engineering. American Jeeps were demonstrably inferior to Japanese prototypes in performance, efficiency, and build quality. American victory came from superior production systems, building adequate vehicles in overwhelming quantities, using available resources and workforce. Shoichiro studied photographs of American assembly lines where workers performed specialized tasks using standardized procedures learned in weeks rather than decades of traditional Japanese mastery. Component manufacturing relied on automated machinery, producing thousands of identical parts with adequate rather than optimal tolerances. The system prioritized manufacturability over individual excellence. Japanese philosophy had emphasized continuous improvement through master craftsmen spending lifetimes perfecting skills. Each vehicle represented accumulated expertise treated as an art form requiring personal dedication and technical mastery. Quality standards exceeded functional requirements because excellence held inherent value regardless of cost or efficiency. The contradiction between Japanese values and wartime necessity had doomed the AK-10 from conception. Building superior vehicles required resources Japan couldn't invest in automotive development. Training craftsmen required time industrial warfare didn't permit. Pursuing superior quality consumed materials that could have equipped multiple adequate units using American methods. Walking through the bombed Toyo plant in late August, Shoichiro saw opportunity among destroyed machinery and damaged structures. "We can rebuild using American principles," he told his father during their daily inspection. "Standardized components, interchangeable parts, assembly line flow. semi-skilled workers performing specialized tasks. This represented fundamental philosophical shift for Toyota. Rather than training master craftsmen building perfect individual vehicles, they could train specialized workers performing specific assembly tasks efficiently. Rather than hand-fitting components to optimal tolerances, they could manufacture standardized parts adequate for functional requirements. Rather than pursuing individual excellence, they could emphasize system efficiency. But transition required abandoning manufacturing traditions defining Japanese industrial identity. Master craftsmen spending decades perfecting skills would retrain for specialized assembly. Precision manufacturing producing superior products would yield to adequate methods prioritizing volume. Quality standards would shift from optimal to acceptable. The captured American Bantam provided the transformation template. Its crude welds represented manufacturing techniques performed by minimally trained workers. Its heavy construction used abundant materials rather than optimized engineering for adequate performance. Its simple mechanical systems prioritized repairability and parts availability over individual refinement. American production philosophies made strategic sense viewed through resource optimization and manufacturing scalability. Building adequate vehicles quickly proved more valuable than building perfect vehicles slowly, when military effectiveness depended on equipment availability rather than individual unit performance. Mass production techniques seeming crude by Japanese standards were actually sophisticated systems converting available industrial capacity into maximum military output. The AK-10 failure taught lessons guiding Toyota's post-war resurrection. Japanese engineering excellence remained valuable applied to production systems rather than individual products. Precision manufacturing could create standardized components rather than unique artisanal vehicles. Master craftsmen could train specialized workers rather than replicate individual skills across entire facilities. By 1957, Toyota would produce 100,000 vehicles annually using hybrid manufacturing combining Japanese precision with American efficiency. By 1980, they would become the world's third-largest automaker, applying AK-10 lessons about industrial warfare's fundamental principles. The company, unable to build enough vehicles for a single regiment, would eventually build more automobiles than any manufacturer in history. The AK-10 lesson wasn't about failure. It was understanding the difference between building better individual products and building better production systems. Standing in his rebuilt office in 1948, Kichiro Toyota kept AK-10 prototype photographs on his desk as reminders of Japan's most valuable wartime lesson. Superior engineering applied to inferior systems produced strategically meaningless results. Superior engineering applied to superior systems would eventually produce both the most and the best vehicles in the world. In industrial competition, as in industrial warfare, the winner is determined by whoever learns to build systems producing the most of the best, not just the best of the few.